So one of the things that I mentioned before was that when you're doing a titration and you want to use a visual indicator of the endpoint, you've got to pick the right indicator. Up to this point, you're probably familiar with phenolphthalein as an indicator, but it's not the only one. And depending on what you're reacting, it might not be the best choice for an indicator. Okay, acid-base indicators are going to have a visual change. Okay, that shows where when you've reached the acid and base equivalence point. Okay, but you've got to choose an indicator correctly so that the color change happens where your equivalence point is. Okay, these are typically organic molecules. They're very complex. They act as weak acids, but when they change color, when the H plus is taken off of them, they change to a different color. Okay, here's phenolphthalein. We're fairly common. This is a fairly common indicator, phenolphthalein, and the colorless form is the acid form. And if you remove the proton from the upper left-hand hydroxyl ion, it changes the structure of the molecule and it changes the color to pink, from colorless to pink. So there's some fairly complex organic chemistry happening in that change. It's not important. What's important is that we have the acid and the base form. The base form is purple or pink, and the acid form is colorless. Okay, a whole bunch of indicators. We usually indicate an indicator, or we refer to an indicator as IN, and then HIN is the acid form, and IN minus is the base form of that indicator. Okay, so for example, one of our indicators, the acidic form is yellow, and the basic form is blue. Okay, so if you add H plus to the solution, it shifts the equilibrium back and makes it yellow. So in the acidic situation, the indicator will be yellow. If you add hydroxide, it shifts it over to the right, and that makes the solution blue. Okay, this is called Bromothymol Blue. That's the name of that indicator that does it. Okay, and this is what it might look like. So more acid, it gets very yellow. More base, it gets blue. If you want to figure out the pH at the endpoint from a particular indicator, we have to make an assumption, and the assumption is that when you can see the color change, that the ratio of the basic form to the acidic form is 1/10. Now we've seen that base to acid concentration thing before in the Henderson-Hasselbalch equation. Okay, so 1/10 of the indicator changes color, changes forms. That's when we can see it. So using the Henderson-Hasselbalch equation and that 1/10 rule, pH to calculate the end point of the color change is pK plus 1, plus or minus 1. So here's a list of some common indicators and where the pH at which their color change actually occurs. And we can use this to answer some basic questions about which might be a good indicator to choose. So, for example, if you are going to use a sodium hydroxide acid base titration, and you see that your equivalence point is somewhere around 7, we've got two possible indicators that you might want to use. So you've got phenolphthalein and you've got methyl red. You have quite a bit of distance around that equivalence point, and so either of those two indicators would be a good choice. Phenolphthalein is a little bit more common, but methyl red would work as well. You'd have because your pH changes so quickly with just a drop added of your base, phenolphthalein's color is going to transform very quickly from colorless to pink, or methyl red from red to sort of a light orangey color. So for strong acid, strong base, you've got a nice big area. For a weaker acid, though, you've got a much smaller area for that change to occur. And so you might have to be a little bit more judicious in choosing which indicator you're likely to use. So here's an example. You want to estimate the pH of a solution in which brome cresol green is blue and thymol blue is yellow. Okay? So let's take a look at the indicator chart. So thymol blue is yellow somewhere between a pH of about 3, maybe 2.7 up to 8. Thymol blue will be yellow in that range. Bromcresol green is only blue above a pH of about 5. So if you want thymol blue to be yellow and bromcresol green to be blue, then you have to have your pH somewhere between 5 and 8. We have a 0.1 molar HCl solution. We add 2 drops of methyl orange. What color is the solution? The pH of a 0.1 molar HCl solution is about 1. Okay? So methyl orange, let's look at our chart. At a pH of 1, methyl orange is red. It doesn't change until about pH of between 3 and 5. So our solution should be red.